In last lecture, we have seen the rank of the matrix. So what is the rank of the matrix? The number of non-zero rows in its row echelon form or reduced row echelon form is the rank. That is the reduce the matrix to row echelon form or reduced row echelon form by using elementary row transformations. And then number of non-zero rows in the row echelon form or reduced row echelon form is equal to rank of the matrix. For example, this is the matrix, suppose. So we have to reduce this matrix to reduced row echelon form. This is the reduced row echelon form of the matrix is this. So this is the echelon form of the matrix. This is the reduced row echelon form, R double dash. This is the row echelon form. So we have to reduce this matrix to either row echelon form or reduced row echelon form. So cancel this word, reduced row echelon form. This is row echelon form, this R dash. So how we can reduce this matrix A to this reduced row echelon form or row echelon form? By using elementary row transformations. That is, first reduce this element to 1, then this 2 element to 0, then this element to 1, then below element 0, and this element is 1. Okay. So if this element is 0, then convert the next element to 1. Okay. So this is the procedure. So rank of this matrix is 3, because if you observe its row echelon form or reduced row echelon form, the number of non-zero rows are 3. So what is the rank of the matrix? We have to reduce the matrix to either row echelon form or a reduced row echelon form. And the number of non-zero rows in this row echelon form or reduced row echelon form is the rank of that matrix. So the number of non-zero rows, if you observe this reduced row echelon form or either this row echelon form, the number of non-zero rows are 3. This is the non-zero row, this is non-zero row, this is non-zero row. So rank of A is 3. So if A is 0 matrix, then rank of A is 0. If A is identity matrix of order n by n order, that is what is the identity matrix of order 3? For example, A is of order 3 by 3 identity matrix. Then what is A? A is 1, 0, 0, 0, 1, 0, and 0, 0, 1. If A is of order 2, then what is A? Identity matrix of order 2, then A is what? 1, 0, 0, 1. That is the identity matrix. This is the, suppose this A is the general identity matrix of order n by n. Then rank of A, or we can denote this identity matrix of order n by n by using this notation I suffix n. That is the identity matrix of order n. I is the notation for identity matrix. Okay, and the suffix n denotes its order. Okay, so what is the rank of this matrix A or In? If A is a identity matrix of order n by n, then its rank is n. Because if you observe the identity matrix 1, 0, 0, for example, I3, identity matrix of 3, order 3, is what? 1, 0, 0, 0, 1, 0, and 0, 0, 1. And this matrix in the reduced row echelon form itself, in a reduced row echelon form. And so the reduced row echelon form of the identity matrix is itself. And therefore, this and the that matrix, if you consider I3, then it contains 3 non-zero rows. And therefore, rank of I3 is 3. Similarly, the rank of In is n. Okay. If A is non-zero matrix, then its rank is always greater than or equal to 1. If the matrix is non-zero, then its rank is either 1 or greater than 1 and is integer. That is, the rank of any non-zero matrix is either 1, 2, 3, 4, 5 up to n. Okay. So rank of any non-zero matrix is always greater than or equal to 1. Is not equal to is not less than 0 or equal to 0. If A is non-zero. If A is 0 matrix, what is 0 matrix means what? All the entries are 0, then rank of A is 0. So if A is m by n matrix, then m by n means this order of A is m by n. That is, A contains m rows and n columns. This m denote rows and n denote the columns in that matrix A. And then rank of the matrix is always less than or equal to m. That is, less than or equal to number of rows. Obviously, if the matrix contains, suppose, 5 rows, then its rank is what? Either less than or equal to 5. Because its echelon form contains how many non-zero rows? Either less than or equal to 5. Then A is if A is a non-zero matrix, then rank of A is less than or equal to m and greater than or equal to 1. That is what is the upper bound of this rank is m and lower bound is 1. Okay, so when we say the two matrices are similar, if we can obtain B from A by using finite elementary row transformations, then we say that the two matrices are similar. So the two matrices A and B are of same size are said to be. Same size means of same order. Is said to be similar if one of these two can be obtained from the other by applying finite sequence of row transformation, row operations. Okay, so we can obtain suppose B from A by using some finite row transformation. Then we say A and B are similar matrices. Okay, so and if A and B are similar matrices, then we say that A is similar to B, or we say A is row equivalent to B. A is row equivalent to B. So A is row equivalent to B. If the relation is A is related to B, if A is similar to B, then this relation is the equivalence relation on S. That is this relation. Okay, S is the set of all matrices of same size. Then we define if A is related to B, if A is similar to B, then this relation is a equivalence relation on the set S. That is, this relation is reflexive, symmetric, and transitive. So these are some examples of rank. So find rank of this matrix. So I have to reduce this matrix to either reduced row echelon form or echelon form. Either we have to reduce its row echelon form or reduce row echelon form. So it's your choice that if you have to find the rank of the matrix, then we reduce the matrix to either row echelon form or reduced row echelon form. Uh, so first consider this matrix A, then reduce this element to 1. It is already 1, so we have to reduce this it below 2 element to 0. So the what is the operation? R2 minus 2R1 and R3 minus R1, or R2 minus 2R1 we can write R2 plus minus 2R1, and R3 minus R1 we can write R3 plus minus 1 into R1. So we have this matrix after this transformation. Then we have to reduce this minus 1 to 1. So the operation is minus 1 R1. So we have the matrix 1 0 2 3 0 1 1 0 0 4 2 3. So what write that matrix? Minus 1 into R1, then write that matrix, and then we have to reduce this 4 to 0. So R3 minus 4 R1, 4 R2, R3 minus 4 R2, because this become plus right here, 4 minus 4 R2. So we have this matrix. Okay, after this operation R3 minus 4 R2, we have this. So write one more step here. After multiplication to second row, this is not first row, right here apply minus 1 R2 operation, minus 1 R2, and then write matrix, and then apply this operation, that R3 minus 4 R2, we have this matrix. And then we have to reduce this minus 2 to 1. So minus 1 half R3 is the operation. So we have, this is an echelon form or row echelon form. It's called row echelon form, or just echelon form. And how many non-zero rows in this echelon form or row echelon form? There are 3 non-zero rows, and therefore rank of A is 3. So we can also reduce the matrix to reduce row echelon form. If you have to reduce the matrix to reduce row echelon form, this is row echelon form. So we have to, if you have to reduce this matrix to reduce row echelon form, then the columns denote the columns that contains leading one. This column, first column contains leading one, second column, and third column, this is leading one. So if you observe the in first column, other than 1, all elements are 0. Other than 1, all elements are 0 in the second column. But in the last column, third column, all the elements except this 1 are not equal to 0. So we have to reduce this 1 and 2 to 0. So we apply one more operation. So two operations, that is R2 minus R3 and R1 minus 2 R2, not R3, R2, R1 minus 2 R3. So after these two operations, we have the reduced row echelon form, and again the rank of A is 3 from that. because again reduced row echelon form is also contains three non-zero rows. Next example, find rank of A by reducing it to row reduced echelon form or reduced row echelon form. So I have to reduce this matrix to reduced row echelon form. So consider A and then R2, reduce this element to 1. So it is already 1. So I have to reduce this 2 and 0 to 0. So 0 is already 0. So we have to reduce this 2 to 0. So operation is R2 minus 2 R1. By using this one, we have to reduce this 2 are equal to 0. We have this matrix. Then we have to reduce this minus 1 to plus 1. So operation is what? Either multiply the second row by minus 1 or interchange the third row and second row. We have R2, 3 is this. Then we have to reduce this minus 1 to 0. So R3 plus R2, we have 0. While converting this to 0, we have this element is also 0. So if we have here non-zero element, then reduce that element to 1. But it is 0 element. So this is an row echelon form. Now we have to reduce this matrix to reduced row echelon form. So the leading one column number 1 and column number 2 contains leading one. So in the if you observe the column number first, uh, other than this one, all the elements are 0. But in the second column, this element is not equal to 0. So we have to reduce this 2 to 0. So operation is R1 minus 2 R2. So we have this matrix. Okay. So 2 and minus 2 are 0. And then minus 4 plus 3 is minus 1. So this is the reduced row echelon form of the matrix A of this matrix. This is the reduced row echelon form of this matrix. And how many non-zero rows in this matrix? There are 2 non-zero rows, and therefore rank of A is 2. So similarly, find the rank of A reducing to row reduced echelon form. So we have to reduce this matrix to reduced row echelon form. So we have to uh, reduce this element 2 to first one, or the first reduce this 4 and 4 are equal to 0. So R2 minus 2 R1, R3 minus 2 R1, we have 0 at this place. Then R3 plus R2, we have to reduce this element to 0 now. 1 R3 plus R2. So we have R3 plus R2, because we have to reduce this element to 0. We have 0. So, and then we have to reduce this element to 1, 2 and 5. So 1 by 2 R1, 1 by 5 R2. And then we have this matrix. And then we have to reduce this element to 0, 1 half. So R1 minus 1 half R2. So this is the procedure. Or first reduce this element to 1, then reduce these two element to 0. That is 1 half R1, right? Apply first 1 half R1 operation. Then reduce this two element to 0. Then reduce this element to 1. That is 1 by 5 R2. And then reduce the below element to 0. We have this. So we have this is the reduced row echelon form, or row reduced echelon form of the matrix A. And this reduced row echelon form contains 2 non-zero rows, because last row is non-zero row. So there are 2 non-zero rows. Therefore rank of A is 2. So reduce the matrix to row echelon form, reduce row echelon form, and find the rank. So again, same example, same type example. This is the element 1. So we have to reduce this 3 element to 0. So this is the operation R13. No need of this R13. Directly reduce this 3 element to 0. Then reduce. After reducing, we have then 0, 0, 0, and then we have to reduce this minus 4 to 1. So we can reduce this minus 4 to 1, minus 1 by 4 R2, or directly we apply this operation. So we have 0, and then we have this is the after 1 by after the all transformation, we have this is the reduced row echelon form, and this matrix contains 3 non-zero rows, and so rank of A is 3. Similarly, find rank of this matrix. Again, reduce the matrix to row reduced echelon form. So by using the procedure, we have this is the reduced row echelon form, and the non-zero rows are 3. This row is also non-zero row. Last row is only 0 row. So rank of A is 3. Find rank of the matrix by using reducing the matrix to echelon form. Echelon form means row echelon form. So this is the row echelon form. So what is the procedure? first reduce this element to 1. So then reduce the below element to 0, all 3 element to 0. Then reduce this 3 to 1. So R2 3 and in change the sign. If you apply 1 by 3 R2 operation, then we have the fractional number. So to avoid the fractional number, these two operation, after these two operations, that is R2 3, interchange second and third row, and then multiply the second row by -1, we have 1 at this place. Okay, so I avoid the fractional numbers, because fractional numbers calculation is somehow tough than this calculation. So avoid the fractional number as far as possible. So this is the one. Then we have to reduce this 3 to 0, R3 minus 3 R2. So this is an echelon form. This is an echelon form because we have 0 row at the last. All the elements in the last row are 0. And therefore this matrix contains 3 non-zero rows, and therefore rank of is 3. So similarly find rank of this matrix. So by reducing the matrix to echelon form, this is echelon form, the number of non-zero rows are 2, therefore rank of A is 2. So these are some problems for homework. Find the rank of this matrix by reducing the matrix to reduced row echelon form. So all these examples, the answers are given, their echelon forms are given. So next topic is system of linear equations. So this is non-homogeneous system. A11x1 plus A12x2. What are A11, A12, A1n, A21, A22? All these are constants, real numbers. A11, A12, all real numbers. And B1, B2, Bn are also real number. So here not all B's are 0. That is B1, B2, Bm are not all 0. If all are B1, B2, Bm all are 0, then the system is called homogeneous system. So this is the homogeneous system. This is the non-homogeneous system. That is equal to all these B1, B2, Bm are 0. Then system is called homogeneous system. And we can write the system in the matrix form. So write the system in the matrix form like this. This is called coefficient matrix. A11, A12, A1n as the first row. Then A22, A21, A22, A2n as the second row. Similarly, AM1, AM2, AMN as the mth row. And the column matrix X1, X2, Xn, the unknowns, and the constant of matrix constant of constant B1, B2, Bm. So this is the system in the form Ax A. This A is X is equal to B. So what is A? A is this. It's called coefficient matrix. Then X is what? This X1, X2, Xn column matrix is called matrix of unknown, and this B as B1, B2, Bm as the matrix of constant. So we can write the system, homogeneous system or non-homogeneous system in matrix form. Obviously, if the system is homogeneous, then this matrix of constant B is what? 0, 0, 0. Column matrix 0, 0, 0. Okay. So Ax is equal to 0 is the matrix form of the homogeneous system, and Ax is equal to B is the matrix form of non-homogeneous system. And the augmented matrix, we denote A and B combine matrix of A and B as an augmented matrix. This is augmented matrix of this given system, combination of A and B. So this is A1, A2, A1, A11, A12, A1n, A21, A22, A2n, and AM1, AM2, AMN. And this is B1, B2, Bm as the matrix of constant B1, B2, Bm. So this combination of A and B is called augmented matrix of the given system, and denoted by this notation A oblique B in square bracket. This is the notation for augmented matrix. A, combination of A and B, matrix of coefficient and matrix of constant. This combination is called AB. The homogeneous system, if the system is homogeneous, then all these elements are 0, and we can write the system in the matrix form as Ax is equal to 0. What is A? A is this matrix, X is this matrix, 0 is the 0, 0, 0 matrix, column 0, 0 matrix. Okay. Then when we say the system is consistent and inconsistency of the equations. So if the system has at least one solution, then system is called consistent. And if the system has no solution, then we we say that the system is inconsistent. That is, the system has one or more solution sets, then the system is of equations is said to be consistent. Otherwise, the system is called inconsistent. So, when the system is consistent, if the system has at least one solution, that is one or more solutions, then system is called consistent. Otherwise, that is, if the system has no solution, then we say the system is inconsistent. And the condition for non-homogeneous system, when the non-homogeneous system is consistent. So if the system is, suppose Ax is equal to B is the non-homogeneous system, then this system is consistent if rank of A is equal to rank of AB is equal to R. What is AB? AB matrix means the combination of A and B, augmented matrix. If rank of A and rank of AB both are same, then we say the system is consistent. This system Ax is equal to B. And when the system is inconsistent, Ax is equal to B, if rank A is not equal to rank of AB. And if the system is consistent, then there are two cases. Either system has unique solution, that is only one solution, or infinitely many solutions. Suppose rank of A is equal to rank of AB is equal to R, number R. And if this R and N, what is N? N means the number of unknowns in that system, number of unknowns in that system. So if these three are equal, that is, if rank of A is equal to rank of AB is equal to number of variables is equal to N, then we say the system is consistent and has unique solution. And if this rank of A is equal to rank of AB is equal to is strictly less than N, that is number of unknowns in that system, then system is consistent and the system has infinitely many solutions. So, and if the system is inconsistent, means system has no solution, that is system has zero solutions. So if you consider any non-homogeneous system, then how many solutions we have for this non-homogeneous system? What are the probable answer? Either the system has no solution, means zero solution. Either the system has unique solution, means one solution, and the system has infinitely many solutions. Okay, so there are only three cases. If the Ax is equal to B is any non-homogeneous system, then system has either zero solution or one solution, exactly one solution, or infinitely many solutions. The middle case is not happen for any system. That is, system has only two solutions, three solutions. It is not possible. The system, if you consider any non-homogeneous system, X is equal to B, then the system has either zero solution, one solution, or infinitely many solutions. So the probable answer of number of solutions for any non-homogeneous system is what? 0, 1, and infinity. Okay, so if the system is homogeneous, then consider the augmented matrix A0 and reduce this matrix to echelon form. That is, find rank of A and rank of A0 both are same. So when the homogeneous system is consistent, if the homogeneous system is always consistent, that is, there is no case that the system is inconsistent, because rank of A and rank of A0 both are same always, and therefore rank of A and rank of A0, because A and A0 both are same matrices, and so their rank are same, and therefore homogeneous system is always consistent. And we know that when the system is consistent, if system has solution, at least one solution. So when this system, what is the trivial solution of this system? X1 is equal to 0, x2 is equal to 0, xn is equal to 0. If we take x, all the values of unknowns are equal to 0, then what we have? The first equation satisfied, the second equation satisfied, the last equation also satisfied by these values of x1, x2, xn. That is, take x1 is equal to 0, x2 is equal to 0, xn is equal to 0. So this is called trivial solution. And so every homogeneous system has at least one solution. And what is that? X1 is equal to 0, x2 is equal to 0, xn is equal to 0. And therefore homogeneous system is always consistent. There is no case that homogeneous system is inconsistent. So only there are two cases: either the system has infinitely many solution or finite solution. So rank of A is strictly less than number of variables, then in that case the system has infinitely many solutions. And if rank of A is equal to number of unknowns in that system, then system has unique solution. So homogeneous system is always consistent, and the homogeneous system has either unique solution or infinitely many solutions. So these are the two cases. So we will see the two methods to solve the system of homogeneous system and non-homogeneous system. So first is Gauss elimination method. So in this method, augmented matrix, that is A, B, is reduced to row echelon form, and the back substitution, we will find the solution of the system. So what is the Gauss elimination method? First, reduce the system to matrix form, then write augmented matrix, that is combination of A and B, and then reduce the matrix, augmented matrix AB to reduce row echelon form, and then find the solution. So this is the Gauss elimination method. And what is the Gauss-Jordan method? In this method, the augmented matrix is reduced to reduced row echelon form. In this matrix, in the Gauss elimination method, we have to reduce the augmented matrix to row echelon form, not reduced row echelon form, row echelon form. And in the Gauss-Jordan method, we have to reduce the matrix to reduced row echelon form or row reduced echelon form, or reduced row echelon form. And then we have to find the solution of the system. So this is the difference between these two methods, Gauss elimination method and Gauss-Jordan method. That is, in Gauss elimination method, reduce the matrix, augmented matrix to row echelon form, and in Gauss-Jordan method, reduce the augmented matrix to reduced row echelon form. So we will see the examples on these two methods in the next lecture. That is, we will see the solution of the system by using the either Gauss elimination method or Gauss-Jordan elimination method. So we will see the examples in the next lecture.